The sixth lecture video on temperature and heat will cover thermodynamic equilibrium. Thermodynamic equilibrium, or the method of mixtures, is when we have two substances initially at different temperatures and we mix them together. Heat will flow from the warmer substance to the cooler substance until their temperatures are equal. Assuming no heat is lost in the system, we can use the same equation we saw in the last lecture for heat. So we can say in the metric system that Q equals m mass times C specific heat times delta T change in temperature. If we have English units, we can say that Q heat equals W weight times C specific heat times delta T change in temperature. In order to have equilibrium between the two substances, we can say that Q lost or heat lost by one substance is equal to the Q gained or heat gained by the other substance. The equation that we will actually be using then is that C sub L times M sub L times the quantity T sub L minus T sub F equals C sub G times M sub G times the quantity T sub F minus T sub G, where the subscripts of L stand for the warmer substance, which lose heat, and the subscripts of G stands for the colder substance, which gains heat. The subscript of F stands for the final temperatures of the mixture. When we are solving problems using this equation, it may be easiest to directly substitute right into the equation, especially if we are trying to find the final temperature. Let's take a look at a thermodynamic equilibrium example. If 225 grams of aluminum at 180 degrees Celsius is added to 775 grams of water at 15.0 degrees Celsius, find the final temperature of that mixture. First, we will write down all of the information we know. The aluminum starts out at a warmer temperature, so it will be losing heat. Therefore, anything aluminum related will have the subscript of Al. The water will have the subscript of G. The mass of aluminum, M sub Al, is 225 grams. The specific heat of aluminum, C sub Al, is 0.220 calories per gram degree Celsius. The temperature of the aluminum, T sub Al, is 180 degrees Celsius. Moving on to the water, the mass of water, M sub G, is 775 grams. The specific heat of water is 1.00 calories per gram degree Celsius. The temperature T sub L of the water is 15.0 degrees Celsius. We are trying to find T sub F, the final temperature of the mixture. The basic equation we will use to solve this problem is that C sub L times M sub L times the quantity T sub L minus T sub F equals C sub G times M sub G times the quantity T sub F minus T sub G. The algebra can get a little tricky in this problem if we try to rearrange to solve for T sub F, so we are going to directly substitute into this equation. This gives us 0.220 calories per gram degree Celsius times 225 grams times 180 degrees Celsius minus T sub F equals 1.00 calories per gram degree Celsius times 775 grams times the quantity T sub F minus 15.0 degrees Celsius. We can multiply and simplify and see that we are left with 8,910 calories minus 49.5 calories per degree Celsius times T sub F, and this equals 775 calories per degree Celsius times T sub F minus 11,625 calories. Simplifying further by getting all of the terms with T sub F to one side of the equation, we have 20,535 calories is equal to 824.5 calories per degree Celsius times T sub F. This gives us a final temperature of the mixture of 24.9 degrees Celsius. Again, we see that water barely changes temperature, while the aluminum's temperature changes quite a bit. This concludes our discussion on thermodynamic equilibrium.